Hello, this video is Introduction to Integration. So, integration and differentiation are two sides of the same coin. They undo each other. So let's talk about both of them and see how they relate and how they differ, and then we will begin to talk about the rules for the integration. Just like we have rules for the derivatives, we also have rules for the integration. So side by side, here are the two concepts, the derivatives and the integrals. The notation for the derivatives, we have two notations, either Newton, which is the prime, or the Leibniz, which is the differential operator. For the integrals, we have this elongated S symbol, which stands for the summation of the function, and the dx tells us what variable we are using. It's the same notation as in Leibniz notation, so this means integral or antiderivative of the function with respect to x. Now, what does derivative do? The derivative finds us the slope at one point on the curve, not between 2 points, but at one point. The derivative also finds us the instantaneous rate of change, which is also known as velocity. If we take two derivatives of a function, we get acceleration. Or if we take one derivative of velocity, we get acceleration. Now, for the integrals are called antiderivatives. So they undo the derivatives. They are also the inverse function of a derivative. So they undo whatever the derivatives do. The integrals also find us the area under the curve. It also finds us the cumulative function, so it adds up the values. It also can find us the volume of a surface of revolution or volume of some other object. So that's a comparison between the derivatives and integrals. Now, what rules did we have? For the derivatives, we had these rules. These are the main rules for the differentiation. The power rule, how to add and subtract derivatives, product rule, when you multiply two functions, quotient rule, chain rule, when we have function inside a function, and implicit differentiation when the function is not solved for the y. For the integrals, we have the power rule also. We have sum and difference, which is exactly the same as for the derivatives. The product rule is called integration by parts. There is a technique called integration by parts, and what it does is it undoes the product rule for the derivatives. There is no quotient rule for the integrals. For the chain rule, to undo the chain rule, we use U substitution, and there is no rule for the implicit differentiation that is similar to it in integral. So let's look at the first example, the power rule, and compare the derivatives with the integral. So what does the derivative say using the power rule? So the power rule here on the side, let's write what the power rule says. Power rule says that the derivative of x to the n is x to the power 1 less, and then times by that power. So this is our power rule. So applying it to our function, we have 2 times x to the first, or just 2x. So the y prime is 2x. Now let's undo this derivative, and we will take integral of the function 2x with respect to x. Now, in order for us to start with 2x and get back to the x squared, what has to happen? Well, all of these operations must be reversed. And how do we reverse them? Well, we started with x to the n dx. So what do we need to do? Instead of subtracting 1, we now add 1 to the power. And instead of multiplying, we divide it. Plus, there will be some constant that is outside. We'll talk about the constant in a bit. So here is our power rule for the integral. Now let's apply it. We have the x to the first power, so the n is 1. So we're applying the integral, and now we have the y is equal to 2 times x. We add 1 to the power, 1 plus 1 makes 2, divided by the same power as on top. If this is 2, we divide it by 2, plus some constant. The 2 and the 2 cancels off, so y is equal to x squared plus constant. Now, why are these different? why does this have the x squared, and the integral which undoes it gets extra constant? Well, that's because if we had x squared plus, let's say, 3, what is the derivative of x squared plus 3? Well, it's still 2x. What's the derivative of x squared plus 8? Well, it's still 2x because the derivative of a constant is 0. So no matter what this number is, 2, 3, 10, 100, no matter what it is, the derivative of it will disappear and will be nothing. So there is no number. Which means when we're reversing, we have to account for the possibility that there could have been an extra number. And so here is whatever number. And so this is how the integral works to undo the derivative and get us back the original function. So original function was x squared, here it is back. So the power rule is, for the integral, is exactly what we just wrote. We add 1 to the power, then we divide by it, and then there is a constant. So let's do one more example and then we will be done. So here is the integral. We apply the integral to each of the terms, just like we do with the derivatives. So we apply the integral to the 3x squared, then we apply the integral to the 5x, and then we apply the integral to the 8. So here we have, using the power rule, the n is 2, so we add 1 to the power, 2 plus 1 is 3, divided by 3, plus 5. Here is x to the 1, when we add 1 to the 1 becomes 2, divided by the power. Now here is 8, which is no x, or the same as x to the 0. If we add 1 to the 0, it becomes 1, so now we have 8x to the 1 divided by 1, plus c. Now we simplify, 3's cancel, no need to write the 1, and so we have x cubed plus 5 halves x squared plus 8x plus c. And this is the final answer to our integral of this function. And that's it. This is the introduction to integration, and the first rule that we discussed is the power rule. And that's it. Thank you for your time. If you have any questions on anything, please let me know.